This is an applications question. Let's look at the key information. A stadium can hold 25,000 people. In general, the numbers are important. People attending a regular event must purchase a ticket. Fair enough. When the ticket price is 20, the expected attendance is 12,000 people. So €20 for a ticket, 12,000 people. Whenever you reduce the price by €1 from 20, the expected attendance increases by 1,000 people. So you bring the price down from 20 to 19 and an extra 1,000 people come. So first question, if the ticket price was €18, how many people would be expected to attend? So this question is kind of warming you up. So €18. So if for a reduction of €1, there's an increase in 1,000. A reduction in €2, so 12,000 is the original number, plus, what's the reduction in price? So let's annotate here. The reduction in price is €2. Second, oh. So the reduction in price is €2. So this is the reduction, we'll say, or for reduction. Okay, and the extra money the extra amount of people brought in by that is €1,000. 1,000 people for each euro reduction. So €2 times 1,000 is 2,000, so 14,000 altogether. Okay. Now, the next question is this. Let X be the ticket price. So we know that the maximum ticket price is 20. That's the starting point. So we're going down from there. Write down in terms of X the expected attendance at such an event. So it's basically moving on from this. So we're saying we know that 12,000 is the base. We start here. Now how many people do we add? We add 1,000 multiplied by the reduction in price. If X is the new ticket price, the reduction is going to be the difference between 20 and the old price and the new price. So see how it looks like this? Times 1,000 people for each euro reduction. And this is the function you get. So now we have a function of X. So this is the expected attendance, okay, the number of people. Okay, so this is attendance. Now, let's look here. So write down a function f that gives the expected income from the sale of tickets. Okay, so now first this was attendance. Now we're looking for income. Okay, so how would you get income? Well, income with any business is going to be quantity times price for anything, selling a product or a service or anything. Quantity times price. Okay? So keeping that in mind, this is the quantity, the attendance. So this is the price. X is the price of the ticket. X be the ticket price. So multiply one by the other. That's it. This is derivations. We're going to skip that for this lesson. Move on to that in the next lesson. Move to G. The stadium was full. So full. So what is full? That's 25,000 people. Okay? That's full. So 25,000 people. 2 types of tickets were sold. Single for 16 and family ticket for a certain amount. We don't know what that amount is. We don't know how much family ticket cost. And that's a question mark. Okay. So the income from the event was 365,000 was the income. Now, here's the extra information they give us that let us solve it. if 1,000 more family tickets had been sold, income would have been reduced by 14. Okay, so 1,000 more tickets would have been, the income would have been reduced by 14,000. Now the question mark here, what we really want to know is how many family tickets were sold. How many family tickets were sold? So first of all, whenever you have an applications question for a function, you want to label all of your variables. You want to label all of the different pieces of information. If you know them, great. If you don't, call them X or Y or A or B, something like that. So this is what we're doing here. So single ticket price is 16 euro. Family ticket price is Y euro. You could call this anything. We're going to call it Y. We don't know that, but we don't have to find it out. What we want to know is how many were sold. But we will need to use it in the equation. The number of single tickets sold is P. We don't know that either. The number of family tickets sold is 25,000, which is the total number of seats. So the total number of seats is 25,000. So that's the number of people there. So make this clear, seats, or number of people. Okay, number of people minus the single tickets. Single tickets. And we divide by 4. Why do we divide by 4? Because each family ticket lets in 4 people. Each family ticket lets in 4 people. So this alone gives us the number of people coming in on family tickets. Divide that by 4 to get the number of family tickets. So we need to put together 2 equations here. One based on the full income. Okay, so 16 euro times the single tickets plus the number of family tickets times family ticket price equals 365,000. That's equation 1. Now we use the next bit of information they gave us to put another equation together. Okay, so let's see here. So we put the next piece of information together to get equation 2, which is that if 1,000 more family tickets had been sold, so if we add 1,000 to the number of tickets sold, family tickets sold, then the income would have been reduced by 14,000. So 365,000 minus 14,000 gets you this. Okay? And manipulate that to make it neat, to have it in the same similar form of P term, Y term next to this here, and next to the number of tickets for a family, and the constant on the other side. Okay, so just like simultaneous equations, you put these together and you get the answer. You don't have to do it the way they did it, but you have 2 equations here, 1 and 2. Use simultaneous equations to solve them. Remember, the equation you're looking, the variable you'll get in the end is P. But then to get the number of family tickets, you want to minus that from 25,000 and divide by 4.